All right, today we will be talking about the habitable world in which we live in. All right, so first, what are some requirements for life to exist on a planet? So, every living thing, we have some needs. How can we survive on Earth? So, we have water, moderate temperature, meaning temperatures in which we can survive or life can survive. We have oxygen. We obviously need nutrients, right? Energy to create energy. We have to have an atmosphere, and then obviously energy coming from those nutrients. So let's take a peek at water first. So every living thing obviously must have water. We can actually live up to 30 days without food, but we can only live for 3 days without water. So Earth's the only planet with surface water. Mars once had surface water and still has ice on the polar caps. Um, Mars and some of the moons have underground ice, which might melt to produce water. And Europa, which is Jupiter's moon, has vast oceans beneath its outer shell of ice, which is a pretty cool thing to think about. So moderate temperature. Earth's proximity to the sun determines its temperature. So proximity, right? Distance from the sun, it's in relation. So life is limited to a temperature range of 15 to 115 degrees Celsius. Proteins and genetic material, that DNA we love, begins to break down at temperatures above that limit. So meaning that it destroys that genetic material above 115 degrees Celsius. And then chemicals in living cells react too slowly in temperatures below 15 degrees Celsius. All right, so atmosphere. So there's a little graphic up in the top right corner there showing Earth's atmosphere of 78% nitrogen, 21% oxygen, and then that 1% of the beautiful other. So atmosphere is held in place by gravity. It insulates the planet, protects us from meteorite impacts and radiation, and it provides chemicals needed for life such as nitrogen and carbon dioxide, CO2. So small planets and moons don't have enough gravity to hold an atmosphere. All right, so if they're not large enough, they're not going to be able to have enough gravitational pull to be able to have the atmosphere there. Of the solid planets and moons, only Earth, Venus, and Titan, which is Saturn's moon, have significant atmospheres, meaning an atmosphere that we recognize as an atmosphere. Mars is about 1/100th that of Earth. So too small for any insulation or shielding from harmful radiation, temperatures, that type of thing. Energy. So light energy from the sun or chemical energy is needed for life processes, right? Producers, they can't make that food. They can't go through that beautiful photosynthesis without it. The sun provides the energy needed for plant growth. So if there's too little sunlight or too few chemicals that provide energy to cells, us as organisms, we need those chemicals, right? We don't technically need sunlight to thrive, but we need energy, so we need chemicals in order to survive or we die. The inner planets get too much sunlight for life, and the outer planets get too little, right? So if you're too far away, you're not getting enough, so producers can't produce, and too close, those producers are, they're getting fried up. Nutrients. So nutrients are chemicals needed to make proteins and carbohydrates for growth, which we need for energy. These nutrients are cycled in the earth, so planets without systems to deliver nutrients to its organisms, something such as like the water cycle, volcanic activity can support life. So when nutrients are spread so thin that they're hard to obtain, such on a gas planet, life cannot exist. So if you don't have enough nutrients in a certain amount of space, like I said, spread too thin, then no life. Recap time. All right, our first set of recap time questions look like this. So what are the ingredients needed for life? Which planet once had surface water and now has deposits of underground ice? Number 3, what determines Earth's temperature? And then finally, number 4, in what ways does our atmosphere make Earth habitable? All right, some accommodations for manned space exploration. So we'll go over this a little bit more later, but just some general things here. Oh my goodness, we're flipping around slides. There we go. So the first human being to travel into space was Yuri Gagarin from Russia, or formerly known as USSR, in 1961. And that was followed a month later by United States, USA, Alan Shepard. All right, so challenges to living in space. Well, there's no oxygen, tough to breathe. No air pressure, no water, very, very low gravity, which we call microgravity. And then, can sound travel? No. So the spacesuit, this provides oxygen, helps maintain our air pressure, protects us from that harmful radiation, extreme temperature, and it protects us from space dust. Microgravity. So because of microgravity, muscles, when you're in space, can atrophy when they're not used. And also calcium is lessened, so that reduces bone loss or creates bone loss. So the remedies for that are daily exercise. So they have some sort of exercise equipment on there. Could be a stationary bike, could be a treadmill that you kind of strap yourself to. Some other issues, some psychological issues in space. So stress and anxiety obviously is pretty stressful. Depression and insomnia can also set in. All right, our final recap time set of questions for this video. Number one, what are some challenges to living in space? And then what are some accommodations for dealing with those challenges? All right, thank you for watching. Enjoy.